Hey everybody, this is Mr. Munson and we are in Unit 7. This is 7.1, Basics of Right Triangles and the Pythagorean Theorem. Um, let's go ahead and get started. This is a really cool unit where we learn some trig functions which you've never dealt with in any previous class most likely. And so we're going to learn sine, cosine, tangent, brand new buttons on your calculator that have been sitting there staring you in the face for probably at least 9 years of your life. All right, let's get going. Let's make sure to set up your notebook correctly. If you haven't done it already, please make sure you draw a line and put a summary for the item above or the unit that we just finished before this. And let's go ahead and put your date in there. Remember, these question mark columns here are for if you have questions during the video. Go ahead and write them in there, and so that when you come to class, you can ask them and find them quickly. In the world of right triangles, we have some specific parts that we'll need to identify. So one of your I can statements for Unit 1 is that I can identify the legs. And so if you take a look, this side right here we'll call L1. This side right here we'll call L2. And the reason that we call these two the legs is because they actually are the two sides that make up the right angle. Okay? Of course, that leaves the third side, the side that's across or opposite the right angle, to be called the hypotenuse. Remember, the hypotenuse is always the side opposite the right angle. All right, so you should have already done your vocabulary words on this section, so hopefully this stuff is not too difficult. Sorry for that blowing of a whistle in the background. But in any case, here's a right triangle, and so side AB and BC, look up at those in the drawing course, are what vocabulary word to angle B, okay? And so the word I'm looking for is that they're adjacent. Adjacent sides are sides that make up an angle. They actually form the angle that we're talking about, okay? Now I know that they make it up because if you look at the names AB and BC, they both have a B in it, right? So I know that they're part of the sides that are the two sides that make up angle B. Contrary, if you take a look at side AC, right? AC is what to angle B? And hopefully you'd say opposite, right? And I know it's opposite because it doesn't even have B in the title. It's on the opposite side, okay? All right, another I can statement is that I can use the Pythagorean theorem to solve for missing sides, okay? So remember, if I have a right triangle, right? So I have to know the triangle has a right angle. If that is true, right? Then I know the Pythagorean theorem actually works. Okay, if I don't know if it's not a right triangle or I don't know, I can't use Pythagorean theorem, right? All right, so let's take a look at these two problems. I'm going to zoom in on them. So we'll just take the appropriate sides and put them in their place. Okay, now that 4 times the square root of 3 squared is something you're going to want to learn how to work with without using a calculator. It's going to be really important that we can keep these things in radical form. So I'm going to do that work off to the side. Make sure you pay attention and you see how I'm working this through. All right, so 4 squared is 3 times 4 squared is 3 is written there. That's the same thing as it being squared. Now this is basically 4 numbers that are being multiplied. 4, a square root of 3, a 4, and another square root of 3. And it's all multiplication, so I can change the order how I want, just like that. Now 4 times 4 is 16, and the square root of 3 times square root of 3, I've identified over years of doing math that that's the same as the number 3. Square root of 3 times square root of 3 is square root of 9. Square root of 9 is 3. Do this on your calculator if you need to, or just get to the place where you know whenever you take a radical and multiply it times itself, it kind of breaks that number out of prison and it just writes it as 1. Okay, so now we have 48. Okay? So now we know that 4 square roots of 3 squared is 48. This is 16, and that's equal to x squared. Now I've removed that square root of 16 there, or the square of 16 there. I removed by mistake. So I'm just simplifying. All right, very good. Now that worked out to be a nice number, 8. Okay, so this x is 8. Now the reason I chose the numbers that I did for this problem is again give you additional viewing of how to work with radicals. That's one of the reasons why we did this. We've done Pythagorean theorem over and over. I'm trying to get you into the world of radicals and being able to work with them in a thoughtful way. If you did not understand what I just did with the radicals, just back up the video and watch carefully, maybe pausing and thinking through the next step. Now that you've seen it, try to see if you can guess what the next step is before I do it. That will help you understand it. Now let's take a look at this one. Get it kind of set up properly there. Okay, so again, let's make sure that we all understand this is a right triangle, okay? So let's write down our formula, and then let's see if you can do this one on your own. Come back and check your work in just a few minutes. That 5 square roots of 2, it goes on the C, in the C spot. Put parentheses around that. Try not to do it with your calculator. Go back and look at my notes about how I worked multiplying that through. If you think it through now, you'll own this. It will not be difficult for you. So just take a few more minutes. Go back and look at where I did something very similar in the problem before, and just apply that step by step to this problem. Put me on pause. All right, well, welcome back. Let's go ahead and put our numbers in place as you expected. So I put those in those places. If you did not put it that way, just pause for a second, put it in the correct places, think it through on your own so that you can own how to do this problem, okay? And so that 5 square roots of 2, I can basically write it like this. And so 5 times 5 is 25. The square root of 2 times square root of 2 gives me a 2, because I know square root of 4 is going to give me a 2. In other words, when I take a radical times a radical, it breaks it out of prison and leaves me that 2 there. All right, and then 25 times 2 is 50. Now I want to pause here for a second. If working around the radicals requires you more work, you have 2 options. And you can take advantage of both of them. One is to simply come in and see me, and you and I work together going through problems after problems, just getting you really comfortable working around radicals. It's not going away. And if you understand the basic concepts of the Pythagorean theorem, but you can't get past the radicals, you're not going to get to the right answer. So let's take care of that right away. The other option you can do is if you look in this unit folder for this playlist, you'll see that there's a Reducing Radicals video, and you can watch that video. It's about another 16 minutes of your life, but it goes through a lot of different scenarios and a lot of different problems. And it might fish out where your questions are and fix them, and it might even create additional questions where you can come and see me. All right, so let's continue on. So we know that 5 squared is 2 squared is 50, so let's go ahead and put that into our problem. All right, so we put that 50 into the spot it belongs. Let's just start simplifying. I get subtract 25 from both sides. Then I'm going to take the square root of both sides to get rid of that squaring. That leaves me b equals 5. Now, the sides don't always come out to be nice like that, okay? All right, so what I want to do is just put me on pause for a second now that you know that this side here is a 5. And I want to ask yourself, what do you think these angles are? What would be the actual values of those angles? Now, we could use Pythagorean theorem converse to find out if they're obtuse or acute or whatever, but that's not what I think you should do. What I would want you to do is realize that both these sides are congruent, and that means their opposite angles are congruent. So just think that through for a second and see if you can figure out what those angles should be. Hey, so if you got back here and you realize that they both are 45-degree angles, you're exactly right. Because I have 180, and I'm going to subtract that 90, and that leaves me 90 degrees to be spread out evenly among those 2 angles. So they're both 45, 45. Okay? All right, let's take a look at this. I have 2 lists. I've noticed that many of my students are still having difficulty knowing what we mean when we talk about classifying triangles. When we classify triangles, we classify them by their side information, their angle information, okay? And how we go about doing that is sometimes different depending on what information we give. So what I want you to do is I want you to take these words over here, and I want you to make sure that you know which one of these words is a side classification or an angle classification. So put me on pause and see if you can just list them in a column form underneath the title. All right, and there you are. No particular order other than maybe scalene, isosceles, and equilateral. Scalene, none of the sides are the same. Isosceles, two sides are the same. Equilateral, all the sides are the same. Now remember, if it's equilateral, then the angles are all the same as well, and that's called the equiangular, right? You're probably pretty familiar with. Acute means that all the angles are less than 90, and obtuse means that one of the angles is greater than 90. All right, so let's classify each, let's be able to classify triangles by the Pythagorean theorem converse using, if you know that the triangle, when you plug in the sides, a squared plus b squared equals c squared, then you know it's just a right triangle. Now, we don't know if it's obtuse or right, or obtuse or acute, if it doesn't equal c, okay? So we came up with the three bears theorem. Three bears theorem basically said that if I have the two smaller sides squared and added together and it's less than c, then the c is too big to be a hypotenuse, and therefore we know that it's obtuse. If a squared plus b squared is greater than c, then we know that the side that we thought was a hypotenuse is actually too small to be a hypotenuse, and so now it makes it acute. And then a squared plus b squared equals c squared tells me it's just right. Okay? All right, always check to see if three sides make a triangle first. To do that, you always take the two smaller sides and make sure that it's bigger than the largest side, okay? Nothing about squaring or anything like that. You're just simply adding the two smaller sides together to make sure that they're bigger, that sum is bigger than the largest one. Okay, so let's go ahead and classify each triangle, and remember the warning I just gave you. Okay, so start with the first one here to the left and see if you can classify if it's from the side category and the angle category, and then we'll do the one to the right in just a minute. Put me on pause and come back and check your work. I hope you came back very quickly because you checked to see if it's a triangle first. 6 plus 5 is not greater than 12. Let's do the next one. So go ahead and put me on pause and let's see how you do on this one. All right, welcome back. So, of course, we're going to first check to see if it's a triangle, and 7 plus 5 is definitely greater than 8. That's 12, so it's definitely greater. So we now know it's a triangle. We can continue on. So let's go ahead and plug our stuff in. We got 7 squared plus 5 is equal to 82. Now, since there's no variable here, I'm not solving for anything. I'm checking to see, is the left side equal to the right side? So it's really a question mark. So start simplifying, and I get 74 is greater than 64. That tells me the thing I think is the hypotenuse on the right side is too small. So this triangle is scalene acute, right? Scalene because it's got three sides that are different. Acute because of the statement, the converse statement I have here from the three bears. All right, so let's take a look at this problem. Kind of a blast from the past kind of problem. I have a right triangle above, three sides that belong on that triangle. And so what I would like to do is have you put me on pause and put those sides in the correct place. Remember, across from the largest side is the largest angle. Okay? Now, it might do you well to figure out what angle C is, just so you can make sure that you have all the angles in their order. All right, put me on pause, see if you can do that. Well, for me, one of the first things I'm going to do is I'm going to find out what square root of 2 is. Square root of 2 is 1.41. So actually, in comparison to all three sides, that side right there is the largest side. I know that's going to go across from the right angle, which is the largest angle, right? Okay, so then we have the other two sides, the two ones, and they're going to go here. Now, I know that they go there because I found out that that was 45, that they both would belong there anyway. Across from the largest, if two angles are congruent, right, then the sides across from them are congruent. There's a good example of that. All right, let's take a look at this one. And again, largest side, largest angle, okay? Put me in pause and see if you can do this one on your own. Okay, so again, I'm going to make sure I understand where square root of 3 is on the number line. Turns out to be 1.73. By the way, square root of 2 and square root of 3 are two numbers that are going to appear a lot in this this chapter and in later chapters. So just kind of maybe tuck away in the back of your head. Square root of 3 is about 1.7. Square root of 2 is about 1.4. Okay? All right, well, that tells me that square root of 3 is not the biggest side, but it's the second biggest side. So in the order of things, square or 2 is the largest side. So I'm going to put that on the right. Square root of 3 is the medium. That's going to go across from the 60. And then this one's going to go across from the what I found to be the 30. And so the last thing that we need to do is be able to write our trig functions from memory. Now these are brand new, right? So you're going to have to write these down and think about how you're going to memorize them, okay? So you got sine, cosine, and tangent. That symbol is like a circle with a loop-de-loo. So I just draw a loop-de-loo and then kind of a curly Q on top, right? So that just basically stands for an unknown angle. It's like an X or a Y. It's just the symbol we use in the world of trig, okay? So the sine of some angle is equal to opposite over hypotenuse, okay? Now, you have no idea what that means. We're going to do that in a section. You'll have it, okay? Cosine of an angle is adjacent, okay? So if you can remember those two, you can remember tangent. Tangent takes the opposite from the top one and the adjacent from the bottom one and just puts it in that order. Okay? So if you remember these two with opposite on top, and they look both the same, they have hypotenuse in the denominator, that's the same, then you just remember opposite is on sine, adjacent is on cosine, and then they're written in the same order, top over bottom, on tangent theta. Okay? Okay, that's it. So in the colored areas there on problem number 1, just put the information in where it belongs from the notes. A couple of review problems there at the end. All right, take care.